Welcome back, friends. One of the crucial steps before we go for ML modeling is categorical encoding. So what is actually categorical data and what is categorical encoding? So what is a categorical variable? Any qualitative data like name of color, name of country or name of department is a categorical variable which defines finite number of groups or categories. The examples which we see over here are not having any particular natural order, and so they are placed in the type of nominal categorical variable. The other examples could be gender, marital status, customer churn, yes, no, spam, which has values, yes, no. Now the examples which we see over here like t-shirt sizes or the views, strongly disagree, agree, neutral, or the level of education, and for that matter salary range as low, medium, high. These are having natural order and they are called ordinal categorical variables. In general, categorical variable is any variable which has finite number of values and therefore unlike numerical continuous data like height, weight or income. During training of ML algo, whether belonging to supervised or unsupervised category, we cannot feed text-based data to the machine learning algo. It will give an error. The only thing which we can feed to machine learning algo is a numerical value. So as part of data pre-processing step in machine learning, one of the important steps is categorical encoding, which implies the way to convert text data like names, colors or any categories into numbers so that an algo can understand and process it. You're with me, Anuradha, and today in this tutorial we will be learning primarily two very important types of categorical encoding. One, label encoding. Two, one-hot encoding. So what are these types of encoding? We will be learning concepts followed by complete hands-on, where I'll be showing you how actually it works during real-time categorical encoding. I'm very excited to move forward with you and hope same at your end. I encourage you not to just watch this video but code along with me, and also to subscribe to this channel to stay tuned for many such engaging videos. So let's get started. Dataset which we will be using for understanding categorical encoding is adult income, which I have obtained from public resource Kaggle and is originally available at UCI repository. The target variable over here is income, which has primarily two categories, less than or equal to 50k and greater than 50k. Have a look at this dataset. We will find that it comprises of continuous variables, numerical continuous variables like age, education, capital gain, capital loss, hours, and also categorical variables with finite number of values like work class, education, marital status, occupation, relationship status, race, gender, and native country. Let's load this data set into Jupyter Notebook and analyze it more for the nature of categorical variables. I'm in Google Colab Notebook and I've already uploaded this data using read CSV method, and also I have marked some of the missing values which were marked as question mark as NaN values. So if we have a look at the information of this data set, summarized information, where Panda automatically assigns the data types to these variables, we will see the variable type based on the values, right? So categorical variables are marked as object type, while the numerical continuous variables are marked as int64. Now we can also separate out numerical continuous variables and categorical variables based on these data types using select dtype method, where we can pass data type to this and separate out it into cat column and numerical column. Further to that, as in our tutorial we are rightly concerned about only categorical columns, we'll just filter out our data frame only to contain categorical column by creating another data frame and passing only categorical columns to it. And if we have a look at the information, summarized information of this data set, you will find that the D type of all the columns here is obviously object, and also have a closer look at the memory usage of these columns, which is currently 2.2 plus MB, right? Since machine learning model cannot handle missing values, which is another topic, but for now I will be replacing all the missing values in categorical columns with the mode, which is the most frequent values in the data. Let's have a look at this step where I am converting object D type to explicit category D type. Though this is not a mandatory step, you will find that it gives better performance improvement, better memory usage, and better control over the categorical variables, which we will be looking at shortly. So once we convert it into category data type, then further to that, if we again extract the summarized information using info, we will find that data types have converted into category, and have a look at this value, which has reduced just drastically from 2.2 plus MB to 290.4 KB. Now we have different types of categorical data in our hand, and let's address this problem primarily as supervised classification problem, where income is a target variable, right, and the rest of them are features. Before proceeding with encoding, we will first split the data into train test split data, primarily in order to simulate real world scenario where the model is supposed to encounter new unseen data, which we will keep intact as test data while we perform our encoding on training data first. And once we are done with all kinds of encoding, we will apply the same encodings on the test data. In this data set, we will be using 3 different important kinds of encoding techniques, including label, ordinal, and one hot encoding. The technique which we are applying depends on the nature of variable, whether it is ordinal, nominal, or even whether it is target variable. So let's start with the label encoding technique, what it is. If we talk about an example, let's say we have a fruit category. Let's say we have a fruit variable which has 3 unique values: apple, orange, guava. Okay. We know that in encoding, we are ultimately mapping a text value, which is a categorical value, to an integer. In case of label encoding, we assign unique integers to each of these values like this. But keyword here is, though 0 is less than 1 is less than 2, but these does not mean any particular order. For example, in case of fruit category, we cannot say that apple is less than orange is less than guava. It's just representing, this unique integer is just representing that category. Label encoding is primarily used for target variable encoding. For example, let's say in this case, on the basis of the image, we have to classify the fruit in a category of apple, orange, or guava, and our target class is a categorical variable. We are using label encoding. Let's say in our case, our target variable is income, which has 2 values, greater than 50k and less than or equal to 50k. By applying label encoding over here, we can assign unique integers to these values. That's all. So what we will be doing, we will be using label encoder from sklearn to apply label encoding. So we are back to Jupyter notebook, and first we will be encoding target variable income. And if we have a look at it, we can see, and we already know that it has 2 unique values, which is less than or equal to 50k and greater than 50k. To encode it, we will be importing label encoder from sklearn preprocessing. We could have applied Python method using lambda to allocate 0 and 1 to each of these values, but let's do such that it can be easy for us to handle unseen data like test data or production data. So we will be using scikit-learn over here. Once we have created instance of label encoder, we need to fit and transform the training data. So it will understand what is the fit method over here will understand what is inside the training data. So it will find the two values and it will allocate unique integer to each of these values in transform method. So let's print these values once we have done the encoding. So we have ytrain encoded as this value. So that was label encoding, where we are assigning unique integers, but the order of integers is not holding any particular meaning. Let's move to next kind of encoding, which is ordinal encoding, which is meant for ordinal data which is having natural order, like t-shirt sizes, small, medium, large, or the views, agree, disagree, something like that. And in our case, the education column. So if we have a look at education column categories, we will find these values, right? And right now they are not assigned any order, but what we want them to be in particular order, so that machine learning algorithm get influenced by the values of their importance. And we can also check this whether these are ordered or not with the help of cat.ordered method, which is particular to category data type over here, and it gives us the current value as false, as we already discussed that these values are not assigned particular order. So how do we assign the values first before applying encoding? First of all, we need to come up with the education order, which depends on our domain expertise, right? And we know that this is the education order. We can either assign the order reordering itself by allocating education order to this education column, and if we run this is ordered again, once we assign, it will give us the true thing. Let's just not do it over here. Again, what we can do, we can make use of pandas categorical method to apply both encoding in a particular given order. We will not be using pandas method over here. What we will be using over here, we will be using ordinal encoder from sklearn, so that we can easily handle production data or test data once we have fitted our training data. We have to import ordinal encoder for that. And here, while creating ordinal encoder, what we will do, we will pass this education order. Okay, we can pass a list over here. Right now we have only one education order. So we have created the instance of ordinal encoder. So before encoding, these are the values. If we fetch out the head values, that is top 5 values, and then we do the fit and transform method on the ordinal encoder, which we have instantiated from this ordinal encoder, and there we pass the columns which we want to encode with the help of ordinal encoding. So we fit the data, which looks at the values of the columns and what are the order of these values, and then during transformation method it assigns the value unique integers which are also relevant in terms of their order to the column values. So once we have encoded these values, we will, if we see the new values, we will find these values allocated to, let's say these values, let's say to high school grade the value 8 is allocated. And if we look at the original order, we will find that high school grade is at the index of 8. So this is the order which we feed in, right? And we can also, once we have ordinal encoded, we can retrieve the original categories using categories method. So this is how we do ordinal encoding, and it is slightly different from label encoding in the sense that value of unique values of integer hold meaning. And now the next and very important kind of encoding which we will be doing is one-hot encoding, which is primarily applied to nominal kind of data, which implies that there is no natural order, and we know some of them are like color, department name, and so on. So let's first see how one hot encoding works. Again, let's imagine we have a feature, this time not a target variable but a feature column called fruit. Let's say it is part of one of the supervised learning problem where we have to decide that how a particular fruit is affecting health. Okay, so let's say this fruit feature has 3 unique columns: apple, banana, let's say cherry this time. Okay, now as part of encoding we have to assign number to these variables. Let's see what happens if we apply one of the encoding which we already know, which is label encoding or ordinal encoding. If we apply ordinal encoding, we are clearly passing the message that one fruit is superior to other, which we do not want to do. We do not want to create any bias over here. Again, even if we are passing label encoding over here, it is also going to assign some unique numbers to these variables, right, to these values. And when these values are fed to ML model, it will get the interpretation that one value is superior to other and can contain internal biases. So we cannot use label encoding or ordinal encoding over here. We need third kind of encoding, which only tells in particular column what kind of fruit is present or absent. So this is where we will be making use of one hot encoding technique. So let's say we have this fruit feature with the values apple, banana and cherry. We will have definitely other features from data frame. So what we will do, we will create additional features over here corresponding to each value of this fruit variable. So let's say we name it as fruit underscore apple, fruit underscore banana and fruit underscore cherry. So we have created 3 variables over here corresponding to each value, and what we need to tell in each feature whether this is present in the current record or not. So let's say this is record 1, okay, which has fruit as apple. So here apple is present, so we will mark it as 1 and we will mark the other 2 as 0. Similarly, in second record we have banana, so that implies apple is not present, banana is present and cherry is absent, and similarly for third record. So this is how we are assigning binary values to the feature 1 or 0. Okay, so let's have a closer look at these 3 features and see if we know 2 of the feature over here. Let's say we know fruit banana and fruit cherry is 0. We automatically know we can automatically predict the value of third feature, which is 1. And similarly, we can predict the value of the third feature if we know the value of 2 features. And this is the problem of redundancy or multi-collinearity. And in that case, we need to use a argument, whether we are using pandas or scikit-learn one hot encoder, we can use drop column first, which will basically give us only 2 features, let's say fruit banana and fruit cherry. So if we know that fruit banana and fruit cherry are 0 for this particular column, that means the third value, which is apple, is present over here. And so what we are passing to machine learning model eventually, this list, first we were passing 1 0 0 and with drop first we can pass 0 0. Alright, so this is how one hot encoding works. Let's apply this to our current data set of adult income. So these are the nominal columns which we have identified from our data set, and they do not have, their values do not have any inherent order within themselves. Let's have a look at the number of unique values within each column, and if we run this, we will find number of unique values vary from 2 to 5 and so on till 40, which is the number of unique countries. So first method to perform one hot encoding is pandas get dummy method, which is a very popular method, and here we simply pass the columns which are to be one hot encoded, and we have already talked about drop first, which will remove the problem of multi-collinearity. Let's run this. This will create so many variables corresponding to one value in a column. Instead of true false, we can also have values at 0, 1 by passing the type is equal to int, and we can also check how many columns are created when we are doing one hot encoding over here. So many columns are created, right, from each of the column, and eventually we will see that total number of columns created is around 77. So let's comment this out. This was method 1, which was using pandas getDummy method. So apart from using pandas, we can simply use sklearn's one hot encoder method. As usual, we have to import it from sklearn preprocessing module and create an instance of it, which we can use to fit transform training data for nominal columns. Once we have done fit transform, if we run this and check the type of encoded or transformed value, we will find that it is a sparse matrix type. So let's see what it is. First, let's extract the name of features with the help of a method called getFeatureNames, where we can pass to this one hot encoding instance this method getFeatureNames and nominal columns, and if we print this, it will simply extract these columns and create the features by appending the values to this. We can view this sparse matrix by converting back it into data frame using toArray method and using the columns obtained from getFeaturesOut method. So let's run this. So as you can see, these are the columns, which is similar to the ones which we obtained in pandas getDummy method. So let's proceed further once we have obtained, and let's have a quick look at sparse matrix, which we just talked about. So what you will find if you have a look at this sparse matrix and why it is called so, that most elements are 0 due to each unique category becoming new binary column, and obviously this results in increased memory usage and potential inefficiencies for some algorithms, right? And this needs to be addressed, which is a separate topic in itself. But just to collate over here, some of the techniques which can help to address this are PCA or LDA, which are dimensionality reduction techniques, or we can use some of the feature selection methods, or maybe we can drop columns with low variance, that is, which have almost all the values as same values. Alright, so we can drop those columns. That is for later, right? So this is a sparse matrix which is getting created, and these are the new features which are getting created. Now we have obtained these new features after encoding nominal columns. We need to merge back these new features to the original data set, right? And for that, what we have to do, we have to use concatenate method from pandas and merge these two data frames. That's it. Now, if you remember, when we splitted the data set, the original data set into xtrain and xtest, it would have picked random values, right? And xtrain would not have a sequential index, and that's why we need to reset the index so that corresponding index values can merge together. Once we have merged this, let's see the values, and we can see there are original columns as well as new columns. Now these original columns from which these features are generated, encoded features, these are no more relevant and are redundant and needs to be dropped, and simply we can use pandas drop method to drop these values, especially the ones which are nominal columns and not the others. So we will use drop method, and let's have a final look. So we have education column which was ordinally encoded, and the others which are obtained after nominal encoding, and then we have a white train which was label encoded. So these are three techniques which we have used during encoding of trained dataset, and we also saw what is sparse matrix and how, at a very high level, how we can address the problem of sparse matrix. And now is the final time to apply the encoding to unseen data, which is test data over here. And why we splitted data before doing any data pre-processing is to avoid data leakage and to simulate the real world scenario. Here we have encoders which are fitted on trained data already, and now we need to transform the test data with the help of these fitted encoders. So let's go one by one. To encode the target variable in test data, we will simply use a fitted label encoder and use the transform method, apply it on the test data. And once we do that, let's have a look at few values of encoded test data. So if you see, we have these encoded value of target variable in the test data. Again, I have taken the feature encodings which we have used in the list. We used ordinal and one hot encoding. I guess the name was ordinal. Let's check once. Okay, so the name is ordinal encoder. So let's correct it over here. Alright, so we have two types of encodings over here. In fact, two types of fitted encoders over here, ordinal encoder and one hot encoder. So first we will apply ordinal encoder on education column, which is primarily contained in ordinal column list. So let's apply that. So we have to run this first and then run this. So if you see over here, the education column in the test data is encoded. And what else we can do? We can apply one hot encoding on the rest of the columns in test data. To do so, what we will do, we will again apply that fitted encoder and transform the XTest data nominal columns and convert it back to array data frame. Alright, so I'm very happy to see this error, because this is one of the problem we might face when we treat unseen data. Let me give you an example, especially for encoding. So let's say you train test split data, and for example, some profession column which included doctor, engineer, artist, lawyer, and when the data is split it, the records which went into the training data did not include the value lawyer, while some of the records which went into test data due to this random split contained lawyer value. Now when we did encoding was done on the basis of values, unique values which were available in training data, which were doctor, engineer, artist, while lawyer was missing, and so encoding was not done for that, right? But when we arrive and encode, use fitted encoder on test data which has value which was not available in the training data, we ought to face this kind of error, and this is a real world scenario. And this is where one of the argument comes handy in one hot encoder or ordinal encoder as well, and that is handle unknown as ignore. So let's try that over here. Before we go, let's have a closer look at this problem again. It says found unknown categories while encoding test data, and this category which is not identified is this one. Now let's have a look at column 2 again. So column 2 in case of nominal column is 0. This is ordinal one, so we will say 0, 1, 2. So occupation, and here we can see the similar category called prof specialty, and in test data we have this. One more thing which I would like to highlight over here is that what we have not done before doing even encoding is cleaning this data, right, which can contain missing data, which I did without specifying, but we did not handle inconsistencies in data, because these and these are almost similar categories, but this is messy data which we need to handle first, and this problem would have been taken care while doing data cleaning stage itself. But anyways, Let's fix this problem through encoder when we created one hot encoder instance by passing this handle underscore unknown is equal to ignore argument. Let's run this. And so now with this argument everything works perfectly fine, and this is finally merged test data set. And of course we need to again drop the redundant columns over here, which we know how to do. And with this I'm done with my current tutorial about categorical encoding. I hope I was able to provide practical implementation, insight and concepts about categorical encoding, and it will benefit you. If this is the case, please subscribe and stay tuned for more such engaging videos. For now, thank you.